Here are the answers for 11.2 Part 1. Pause the video if you want to look at these a little bit closer. Next, we're going to look at finding inverses of functions algebraically. An inverse undoes a function. So the inverse of addition is subtraction. The inverse of multiplication is division. The inverse of a square is a square root. The inverse of a cube is a cube root. Inverses are the things that undo math. With everything that we do in math, there's a way to do it and there's a way to undo it. And the undoing is the inverse. And we're going to follow this process. So all of these functions are going to be labeled f of x. Remember, f of x is a fancy way of saying y equals. So we're going to change the f of x to a y. To find the inverse, you're going to take the x and the y in the function and switch them. So the x becomes y, the y becomes x. Then you get y by itself, and then you change it back into function notation, which is f negative 1 of x. This symbol means the inverse of the f function. So here's our first example. Our very first one is f of x equals 2x plus 3. So your first step is that f of x is really a y equals. So we have y equals 2x plus 3. We're going to switch x and y. So y becomes x and x becomes y. Now we need to get y by itself. So I am going to solve this as I would any other equation. Getting y by itself, we're going to start by subtracting 3. So we've got x minus 3 equals 2y. And then we'll divide everything by 2. So we have y equals x minus 3 over 2. When we change it back to that symbol, so f of x is the original, we're trying to get f negative 1 of x, the inverse of the f function. So f negative 1, the inverse of f, is x minus 3 over 2. And now you might notice some things. In the original problem, we had 2 times x, and in the final, in the inverse, we have divided by 2. In the original, we have plus 3, and in the inverse, we have a minus 3. So you can kind of see all these things in here that are going to undo each other. Okay, for part B, our first step is f of x is the same as y equals. Switch the x and the y. So y becomes x, x becomes y. Now we need to get y by itself. So I'm going to add 7 on both sides. So we have x plus 7 equals y cubed. How do you undo a cube? With a cube root. So the cube root of x plus 7 is going to equal y. And now to write this as our final answer, we use the fancy inverse symbol, f negative 1 of x equals the cube root of x plus 7. Okay, that's really all there is to this. Change f of x to y, switch your x and your y, get y by itself, and then replace that y with that fancy f negative 1 of x. Okay, a quick note about the graphs of inverse functions. The graph of the inverse is the reflection of the graph of the original function over the diagonal line y equals x. So here you see that dotted line, y equals x. The black line is the original f function. The gray line is its inverse. If you folded the paper on that dotted line, those two things would match up perfectly. Now, if you're asked to sketch the graph of an inverse function or identify the graph of an inverse function, all you have to do is pick a point or two on this graph. This point is AB. So I'm going to kind of make a little chart here. It's not really like an F, like an XY chart. I probably shouldn't make like a T chart. So f of x, we're switching it to the inverse. So if the original point is a, b, we are going to switch x and y. A is your x value. It's going to become the second number. b was the y value, it's going to become the x value. So you switch that a and b, and it becomes the point BA, and that's a point on the inverse. So on this next example, use the graph of the function to sketch a graph of the inverse function. Now you could just eyeball this. It's not going to be very easy if you eyeball it though. You can make a little dashed diagonal line, try to make it as perfect as possible. But really what I do here is I pick out a couple of points. So this point right here is the point 1, 3. It is going to become the point 3, 1 on the inverse. So then I can graph the point 3, 1. Right here, we've got the point 1, 1. What is 1, 1 going to become on the inverse? 1, 1. So that point is also going to be there. So this thing is going to intersect there. Notice this point is 0, 0. So you can kind of already see that this graph is going to come around like that. And then it's going to do kind of the same thing on the other side. So this point is -1, -1. It's going to also become -1, -1. But the point I really want you to focus on is this point. The point -1, -3. It is going to become the point -3, -1, right about here. So then here, this is going to curve around like this, and then go out to this point. There is our inverse. I think I put that dot a little bit too high. There we go. There we go. And your assignment for 11.2 Part 2 starts on page 573, 13 through 16, 23 through 26.